Welcome to this Universe breakout session, Machine Learning Integration with NetIQ Risk Service. Hello, my name is Kent Purdy. I'm the Product Marketing Manager for the NetIQ portfolio. And with me to do this overview and demo is Grish Kumar, Senior Product Manager as part of the Access Management Group. So with that, Grish is going to first cover some concepts of how we evolved in adaptive access control and how we use the Risk Service and Interset plugin to make that happen. So with that, Grish, over to you.
Thank you, Kent. Hello, everyone. Let's first talk a little bit about adaptive access control and the evolution of adaptive access control. Many of you know and has been using various mechanisms for controlling access to applications in system. Particularly sensitive applications and even everyday applications require authentication and access control. Historically, access management system has been providing ways to do static access control using policies that looks at groups and roles and attributes of the user. Static access control has been around for many decades and has been widely adopted. Over the course of the last many years, or maybe a decade or so, things are being evolving to more dynamic access control mechanisms. This is arised by the need to identify users' activity in controlling access. NetIQ Risk Service introduced the concept of contextual adaptive access into the NetIQ portfolio. What contextual adaptive access does is to look at things beyond the basic policies. It looks at things such as the context of the user's access, where the users are connecting from, the IP address, the location of the user's access, the devices they connect from, and looks at some of the historical elements. Have this user accessed this particular application in the past? Was it a successful access? Are these users with the same profile or the roles supposed to access this application, right? So those basic information along with the contextual information of the user is used for controlling access to sensitive application. And contextual access and adaptive access is now getting very widely deployed. Most of our customers have some form of contextual access control implemented already. But when you look at contextual access control, you obviously see what's missing. It looks at a set of static information that you collect. Even though you know the IP address and location, it does not go beyond these parameters. What we need is a mechanism to look at the behavior of the user in the context in which they are accessing and look at that information for controlling access. And the concept of behavioral adaptive access control does exactly this on top of the traditional contextual and adaptive access. Make no mistake, contextual and adaptive access has a place in every organization. What behavioral and adaptive access control does is to further look at the information that you could collect and use that information to tailor the access based on the user's behavior. We'll see how this can be deployed using the NetIQ tools. As we talk about the traditional behavioral analytics, you often look at things in lines of rules and thresholds. If you look at the risk-based access management that we have, we traditionally create a set of rules. That rules detect what kind of access the user should have. The rule policy might look at things such as your IP address or your location and says that if the IP address of the user belongs to the corporate IP address and the user is connecting from a corporate device, allow them a seamless access. If not, force a two-factor authentication. Now these rules, as you very well can identify, that makes a lot of sense and intuitive in nature. It also provides a way for pattern matching, such as the basic historical elements of the users. However, what this rules does is not to look at a large subset of your historical information and bring the contextual elements of the user's past accesses into the current access discussion. And this is where a behavioral access management system would help you in looking at things beyond what is being missing.
So Girish, one thing I'd like to understand a little bit better, if I understand correctly, as organizations try to create rules that cover a more comprehensive set of situations, especially in a larger environment, that the rules themselves, the volume of them, just become unwieldy in terms of accommodating the different scenarios that they're trying to protect themselves against. Could you explain that a little bit more?
That is true. That is very true. As you could imagine, a larger organization required a wide range of rules to cover all the nooks and corners of the application accesses. It requires to create different set of rules for different types of users and maybe different sensitivity of the applications. The challenge that you see in such scenarios is that your rule policies get really complex, and identifying the right access metrics are always challenging in such a scenario. And this is exactly where the behavioral-based access control triumphs the rule-based access control. In order to support a rule-based, a good behavioral access control, you need a machine learning infrastructure. The machine learning infrastructure provides ways for you to look at things that the normal rule policy cannot in a much, much faster and broader sense. Micro Focus acquired the Interset machine learning, unsupervised machine learning platform, and we integrated the Interset intelligence platform into the NetIQ Identity and Access Management portfolio. What Interset bring in is a very large set of unsupervised machine learning models and algorithms that are pre-created to look at behavior of the users. It allows you to detect abnormal behavior inside the threads and various other abnormalities that can be observed using a user's access, which usually seldom get noticed during a rule or threshold-based access control. In the subsequent slides, we'll see how Interset helps us in identifying some of these unknown threats that are present in the system and in the user's access. Let's look at how behavior analytics work before we jump into a demo. Behavior analytics traditionally looks at a very large set of contextual data. In the NetIQ Risk Service, in the case of NetIQ Risk Service, NetIQ Risk Service identifies the authentication and access control data, as well as some of the historical elements of these data, and share this information with Interset. Interset also have the capability to look at repositories, Active Directory systems, SIEM systems, and your network to look at additional information about the user's access. It does and correlate and create a baseline, and upon which, using that baseline, it detects any abnormalities in the user's access. And it runs a number of machine learning algorithms, particularly unsupervised machine learning algorithms in this particular process. It looks at each and every user's access, compare that with the peer group of this particular user or even users with similar role, and identify anomalous activities. Anomalous activities could be an anomalous access, unidentified, or a lateral movement, or any of the other threats that we would see in the subsequent demo. Further, our identity and access management engine, particularly Risk Service, would gather back the potential risk identified using the Interset machine learning platform and use that information for controlling access or enforcing multi-factor authentication for the user's access. In general, it prevents abnormal access, looks for compromised accounts, and identify unknown threats that can be identified using the traditional mechanisms. Before we get a demo, let's talk about one of the use cases, right? The use case here talks about Joshua, a healthcare worker, works in a healthcare organization which has sensitive applications, sensitive data, probably HIPAA protected data, such as patient records. Joshua, being a physician, has access to all. In this particular example, we created Joshua's system with a system where Joshua inadvertently clicks a malicious URL, and it created an spyware infection to the system. What the spyware does is to do various activities, including identifying access to sensitive information, sharing this information over internet, to lateral movements and other things. We'll see how Interset identifies such a case. And you can very well imagine that a typical risk policy or a context-based analysis engine cannot identify any improper access for Joshua, because traditionally Joshua would be accessing using his own credentials, even using multi-factor authentication, and probably from a corporate device using inside the corporate network. Right? So we'll see how a machine learning algorithm identifies this. All right, good. Let's move on to the demo. We have Access Manager Administrative Console here, where the Risk Service is running. Risk Service is an independent service that can be run with all the Micro Focus NetIQ IAM Identity and Access Management products. In this particular case, Risk Service is directly integrated into Access Manager. Let's look at the risk policies before we get into the user. So I have a couple of risk policies configured, and let me get to one of the demo policies that are configured specifically for this particular demo. So the key thing what we are trying to show in this particular case is NetIQ Risk Service being integrated into the Interset behavior integration platform. We are not walking through the rest of the risk service, but there is another demo that's part of this series where we will be walking through the risk service in detail. Let's look at some of the policies that I've created. We have 3 policies here: a behavior analytics rule that looks at the behavior of the user using the Interset machine learning platform. What we are saying here is that if the Interset turns back with saying the user have a higher risk score, we'll outrightly deny the access to the user. If the rule says that proceed to the next, if it's an IP address rule that violates it, we usually proceed this and then do a control later half. In the control section, you can see that we have 3 controls set, saying that if the risk is low, we would allow the user to access. If it's between a medium range, we would authenticate using a 2-factor authentication. And if it's a very high risk, we will deny the user access. Right? So there are multiple policies. We have further refined control if you like to do. For example, in the risk rules, you have ability to look at different conditions and then assign the different risk score based on that. You can skip over, proceed to the next rule and all. And on the actual control part, you have the ability to look at different risk score, combination of that. You can allow access, deny access, and enforce additional authentication. You can choose different authentication methods for that and vary the risk score based on that. You also have ability to see what's going on real time. On the right hand side, you can see that the dashboard sees what happens if if a particular risk changes. You can toggle this and then find what exactly would be the condition that will be met. Let's move on to the demo. Right? So we have a user here, Joshua Newman. As we looked at, Joshua logged in to the application screen. And there are a number of sensitive applications for which Joshua has access to. As we talked about earlier, Joshua's system was infected, and the infected system has created a number of unauthorized access to different kinds of applications, to applications where Joshua is not supposed to access, or the network systems, and so on and so forth. There is a sensitive application called as Medilab in this particular case, which uses the medical reports and clinical details for Joshua. Joshua, by virtue of being a physician, has access to MediLabs and the patient records. But in this particular case, Joshua being a high-risk user that is being flagged by Interset, you can see that Interset has flagged at very high risk for user, and access denied is enforced by access manager, considering that there is a high risk that has been identified.
So going back to your rules, if there was a lower risk that was beyond 0, Sarah could have been given a prompt for a multi-factor authentication, such as a challenge question or something, but since it was so high, they just actually denied access.
That's correct. If the risk is identified as low, usually the user will be able to directly access this. And if the risk is medium, and of course you have the flexibility to choose what low and medium or even a custom risk score means. But usually we tend to see that if the risk is medium, we would see that the user will be forced for a 2-factor authentication, and a higher risk naturally would stop the user from access. Let us look at the Interset Intelligent Dashboard and then identify what exactly has happened in this case, right? Let's look at the basic dashboard. So this is the overall metrics of anomalies and violation. So let's look at the login initial screen itself. You can see that Interset has analyzed a very large set of events, and out of which it found a set of events as anomalous, and it also found that 19 of those are active high risk. So you can see when a very large set of events, Interset is able to identify that particular needle from that haystack. Interset looked at the users, machine, controllers, IP address, and shares for identifying this. It also has identified or a trend of your overall risk, and shows what's the pattern of each of these risks, and the type of each of these risks and the contribution of each risk. You can see the lateral movement contributed to bulk of the risk, and the top 5 riskiest user. Our user, Joshua Newman, is identified as one of the top 5 risky user. Click on Joshua and then identify what exactly has gone. Right? In this case, you can see that there is a trend, overall trend of activities that happen. Right? You can see that there is a specific trend of high risk, anomaly for Joshua. And after the system has been identified as, system has been infected with this spyware. You can look at the contribution of the higher risk that happened for Joshua, and the specific information. Let's say, for example, I want to look at lateral movement that has happened and the contribution of lateral movement in the overall risk. If you look down, you'll be able to see what exactly contributed to the higher risk. Say, for example, in this case, if you look at it, it specifically walks through the activity that Joshua performed, and it compares that with the peer group of Joshua. It looks at probably users with the same role or similar profile and access permissions and pattern of access. And in this case, it has identified that the user has logged into this particular application a slightly higher number of times in an hour compared to other users. Typical highest that we observed in Joshua in the past is 4, average is 2.3, but you saw that the user has in the recent time accessed 6 times on an average, and this actually is a cause of concern. As you could rightly imagine, an individual event will not represent the actual risk. And an actual risk is can be identified by looking at a combination of a series of action the user has performed. And this is where a machine learning based system performs better than the traditional risk-based or rule-based computation engine. In rule-based computation engine, you would have seen that this is a single rule that we executed. But in machine learning system, you see that there is a series of such observations and the pattern of the user is being looked at to identify the overall risk. Let us look at another, access risk. In this particular case, you can see the contribution of the risk that's happened. Let's look at a particular activity that is performed. You can see that Joshua or the system from which Joshua is logged in has connected to the infrastructure and tried to log into application well past midnight. And this is not the usual pattern of users, Joshua's access. You can see that Joshua's pattern of access regularly is this, and there is a behavioral change that you have observed. What Interset does is to look at each of these individual events and compute the probability of the risk of these events. It combines this information and then comes out with the overall risk score of the user.
So just to clarify here, Girish, I believe what we're looking at here is as time goes by and Joshua is monitored for a longer period of time, these anomalies like 2 a.m. access or 1 to 2 a.m. access become stronger anomalies over time because how rare they are.
That is very true. That's actually a good observation. That's exactly what we are seeing here, right? So in this particular case, as we see more data is being collected by Interset, not just the access information, but also the network information, all the device information, and so on and so forth. The more or better profiling the system can do. It also can look at the peer group of the user, looks at users similar to Joshua, and then find their access pattern and then compare this with the Joshua's access pattern.
Also, their behavior can influence how strongly Joshua's behavior is interpreted as well.
Absolutely, absolutely. Yes, that is one of the capability the system provides. So as you can see, this resulted in a high risk condition. You can specifically look at each of the activities or the time period and then identify that. So there's a trend graph and other things that you can look at, right? So that's one of the capability that the system provides in identifying. Okay, so as you can see, Interset provides you a platform that allows you to look at the overall risk of individual users, and it allows, with a combination of Interset, NetIQ Risk Service allows you to tailor the user's activity and user's access control based on the individual user's behavior, not just based on a set of predetermined rules, but in combination to the rules, it will be able to look at the behavior and also look at the peer group's behavior to control access. It can control authentication and authorization of these individual users, even to broader set of application or even to a micro application or a specific application that you deem as high sensitive.
Yeah, to extrapolate the rules I saw you review up front, the way I interpret it, because this is a healthcare example, is that you had, you could almost argue that the rules were used to comply to mandates, right? HIPAA mandates that when these records are accessed, that multi-factor authentication needs to be implemented to make that happen, to provide that access. But then beyond the set of rules, beyond the compliance that the rules invoked or enforced, you had Interset Analytics identify risks beyond that for another layer of protection.
That's absolutely right, yes.
Thanks so much, Girish, for that demo. That was quite helpful. Please keep an eye out for a couple of other demos that Girish has done. He has another demo where he goes into the risk service with some other rules a little more thoroughly. And he also has a demo about Secure API Manager, right? This is all about securing access to resources that are being accessed programmatically as opposed to just through users. It just is becoming a very hot area right now in terms of protection. In addition to those other demos, there's a couple artifacts that you might want to look at on the Risk Service resource page. This one, Machine Learning and Security Operations Centers, is all about the science of that Interset uses to apply machine learning into security. And this second white paper is your environment adaptive enough for zero trust, is more about the complete access management solution, not just the risk service with the Interset plugin, but also leveraging an access manager, which is the ability to control authorization, as well as advanced authentication to help verify with stronger authentication, multi-factor, for example, to verify the user's identity. So those are two good resources that you might want to look into, and we appreciate you watching this demo.
Thank you.